Here I'm going to take a look at some examples of finding areas of parallelograms. And in this first one I have two things. I want to find the area and I want to find the perimeter. I'm going to start with the perimeter, and I'm going to go back to my properties of parallelograms. I know that the opposite sides are congruent, therefore my opposite sides of other sides that aren't in there will be 10 inches and 23 inches. So if I want to find my perimeter, all I need to do is add up all the sides. So take the 10, the 23, the other 10, the other 23, add those all together, and I end up with 66, and then don't forget your label, inches for the perimeter of my parallelogram. Now the area, remember when you talk area, you need to know how long the base is and you need to know how long the height is. Start with my area there. Well, I look up here and I go, well, I know the length of the base. Can use either 23. So there's my base, but now I need to figure out how long is the height. Well, the height I would put in right here. Not the only place you could put it in, but that's where I would put it in. You know, it makes a right angle. Now I look at just the triangle out there that's been created right here, and I notice that I have a 45, 45, 90 triangle. Well, I know that all I need to do to find the length of a leg, when I know the hypotenuse, is divide the hypotenuse by the square root of 2. So I'm going to do that right now. I'm going to take my 10 and divide it by the square root of 2 and find the length of the leg, which is also the height of the parallelogram. Now I can't leave it like that, so I'm going to fix it, I'll say. I end up with 10 root 2 over 2, which is the same thing as 5 root 2. Therefore, I know that the height of my parallelogram is 5 root 2. Now I can come back to my area formula. Area is equal to base times the height, and I'll have the area of my parallelogram. And I end up with 115 times the square root of 2, and now I need my label, and area is always going to be in terms of square inches, because area is really asking for how many little squares fit inside of your figure. Well, there'd be 115 root 2 little 1 inch by 1 inch squares that fit in there. Now if I wanted to approximate that, I can take that and just type that on my calculator, and when I do that I end up with 162.63 square inches. So depending on which answer it wants, whether it's exact, the first one, or the approximate, the second one, I found the area of my parallelogram. Now my next one, very similar. You know, my perimeter, just going to fill in my opposite sides, 12 centimeters there, 15 centimeters here. So my perimeter, I'm going to add up all my side lengths, 12, 15, 12, and 15. I end up with 54 inches for my perimeter. And then to find my area, similar to last time, I'm going to need to go through here and I'm going to need to actually calculate the height first. So I'm going to draw it in so that I can see it. It's going to end up right there. And then my height is part of this triangle. And I notice that triangle is a 30, 60, 90 triangle. And in this triangle, I know the hypotenuse again. Well, if I know the hypotenuse, the short leg is half of it. So this part would just be 6. Remember, multiply your short leg by root 3 to get to the long leg. And the long leg is the same thing as the height in the parallelogram. Now I can come over here and I can calculate my area of my parallelogram. My base, which would be the 15 centimeters. Multiply that by the height of my parallelogram, which I found out to be 6 root 3. Multiply those two things together, and I have my height, or excuse me, my area of my parallelogram. So 15 times 6 is going to put me at 90 times the root 3, so I have 90 root 3 centimeters squared. And I just noticed that I made a mistake up here. My label wouldn't be inches, my label should have been centimeters. Now I can also type that on my calculator to come up with the approximate area of the parallelogram. And the approximate area comes out to be 155.88 centimeters squared. Now my next one, maybe a little more applicable. Someday you're going to want to put carpet in your house, and you're going to want to know approximately how much it would cost, so you're going to need to know how much you actually need. So in this one, I want to carpet the 3 different rooms. I want to carpet the living room, I want to carpet the den, and I want to carpet the hallway. Well, I noticed that I have rectangles here, which are parallelograms, so I could go through and just figure out the area of the 3 different rooms, add them all together, and I would know how much carpet I would need. So I'm going to start with my living room. So the area, and I'm just going to do a little sub L for the area of the living room. My base in my living room is going to be 15. My height is 13. Multiply those 2 things together, and I end up with 195 square feet of carpet that I'll need for that room. I can move on to my den. So the area of the den. Again, the base of this one's 15. The height of this one's only 9. So I multiply those 2 together, and I end up with 135 square feet of carpet for that room. And then I have to go and I have to find the area of the hallway. Well, I look at this and I don't know the base right now. It didn't tell that to me. But what I do know is that this length here is 35. Therefore, when I go to the bottom of this house, think of it as the bottom, that's going to be 35 feet as well. So if I want to find the part that remains, I can do 35, subtract out the 15 feet from the den, subtract out the 15 feet from the living room, and I find out that the hallway is only 5 feet wide. So now I have the base of my parallelogram. The height of my parallelogram is equal to the height of the living room, which was 13 feet. So 5 times 13. I need 65 square feet of carpet for that room. And now it's just a matter of adding all those together. So when I add all those together, the plus signs in here, I end up with 395 square feet of carpet that I'm going to need to carpet my rooms. So now you can go into the carpet place and say, I need 395 square feet of carpet for my house, and they can give you a quote, and you can say, yes, that's good, or no, that's not, and go on from there. Now, my kind of last example, it's a 2-parter. First, I want to figure out what kind of quadrilateral is this. So, we've done problems like this. First thing to do is we need to go through and we need to just graph it. So we have -2, 3, which is going to be approximately here. We have 4, 1. B, C is at 3, -2. And D is at -3, 0. There is my quadrilateral. And now I want to figure out what kind is it. So is it a parallelogram? Maybe it's a rectangle, maybe it's a rhombus, maybe it's a square. So the first thing that I'm going to do is I'm going to go through and I'm going to calculate the slopes of the 4 sides. So I'm going to find the slope to start of segment AB. So I do my slope formula. I'm going to go A minus the B for the Y values, and then I'll have to do the same thing for the X values. Oops, not 6. The B value, or the X value at B is 4. So I'm going to end up with 2 over -6, which is equal to -1/3. So the slope up here, so I'll put my slope up here of -1/3 just for reference, make it easy to see. Next I'm going to go to segment BC, find the slope of that one, since that's opposite segment AB. That'll give me an idea of whether this thing is looking like a parallelogram or not. So I'll subtract my X values, I'm going to do this, or excuse me, the Y values, I'm going to subtract the C minus the D, and I'll have to do it in the same order for the X values. And here I'm going to end up with -2 over 6, which is -1/3 again. So I know those 2 sides are parallel. Now I'm going to go to my other 2 sides. So now I'm going to do the slope of segment AD. And here I'm going to do Y value at A minus Y value at D over X value at A minus X value at D. Here end up with 3 over 1. So the slope of this one is 3. So now I notice when I look up here, I go, well, I have a right angle here and I have a right angle here. But I still don't know if it's a parallelogram or not, so that may or may not help me with the right angles. And then I just need to finish it out and find the slope of segment BC. So I'm going to go by value minus cy value, and then bx value minus cx value. And here I end up with 3 over 1 again. Slope of this one's 3. So now I look at it, my opposite sides are parallel, which tells me it's a parallelogram. I look at my consecutive sides, and they have slopes that are opposite reciprocals, which mean they're perpendicular and have right angles. So I have a rectangle here. Now what I want to figure out is it also a rhombus? Because if it's a rhombus, then I know it's a square too. So the way I'm going to check to see if it's a rhombus, I'm going to check the length of segment AB, and I'm going to check the length of segment BC. Because I know it's a parallelogram, once I know one side, I know the opposite length as well. So I'm going to have to use my distance formula. So I'm going to find the length of segment AB, like I said. So length of segment AB using my distance formula. So now I need to subtract my x values, -2 minus 4. I have to square it, add on then my y values subtracted. So that'll be 3 minus 1 squared. And it's just a matter of going through and kind of simplifying the mess, I say. So here's -6 squared plus 2 squared. Puts me at 36 plus 4. Take the square root of that. I'm going to have the square root of 40. And I'm just going to leave it like that for the time being. That's as far as I really need to go for what I'm doing. If I had to find the actual length, I wouldn't leave it that way. I'd simplify it, or I would round it to 2 decimal places. And then I want to find the length of segment BC. So the length of segment BC is going to be equal to, and I got to do my distance formula again. I'm going to do 4 minus 3. I square that, plus the 1 minus -2 squared. So I'm going to have 1 squared plus 3 squared. And that's going to put, and don't forget my square root, 1 plus 9, which is going to put me at the square root of 10 for the length of segment BC. So this one had a length of square root of 10. This side had a length of the square root of 40. Guess I should have put that in pink. I'll fix that for us so it matches. Square root of 40. Now, I noticed that my sides are not congruent, so then it's not a rhombus. So when it's all said and done, when it asks what type of quadrilateral it is, I know that it is a parallelogram, and it is also a rectangle. And now my next one, this one I want to know, what is the area of the quadrilateral? Well, being it's the same one as this one, I now know the length of the base. I know the length of the height. Well, then I can just come over here, and area of a parallelogram is equal to base times height. Well, I just said that my base was the square root of 40 long. My height was the square root of 10 long. If I multiply those two things together, that's going to equal the square root of 400, which is equal to 20. So 20 square units is the area of that quadrilateral, or rectangle in this case. And that's going to conclude the example portion of my lesson on areas of parallelograms.